I'm unable to be there with you this evening at the Rust AU get together in Sydney. I intended to have a chat with you about Embassy, which is an embedded async framework. In fact, Embassy means embedded async, and that's how the name was formed. And I've come up with this crazy title, Refuge in the Embassy, because look, I think that Embassy is just the best thing to use to write embedded software with Rust. In particular, because of its async capabilities. And why is async important in the embedded world? We have these single core processors that can't apparently do multiple things simultaneously. Well, of course, with these microcontrollers that we have nowadays, there are multiple peripherals surrounding the microcontroller, and the fact is many things can occur concurrently or even in parallel, given that we have, for example, a UART that may be doing things with the serial port, therefore, and we may have a analog digital converter sampling things. And so there is this opportunity to context switch between many tasks so that we can seamlessly do things. So while we're waiting on the UART to give us some bytes, we may be doing some processing with the analog digital converter and so forth. Anyway, before we get into that incidentally is the primary use case in my book. So we can do things concurrently. The major benefit being that the async benefit is that you are able to do more things in a shorter amount of time, and that equates to energy efficiency at the end of the day. And energy efficiency is good, particularly with microcontrollers. The less heat there is, the better condition circuit boards can therefore perform in. And indeed, if you're powering these electronics also with batteries, then it becomes even more important. So that's why it's important. So my name is Christopher Hunt. I'm from a company called Cuprous, and we build hardware and software. We're currently involved in the energy industry, building electric vehicle chargers, and we use Rust pretty much for everything, for our microcontrollers, for our back-end cloud services, for our front-end, and so forth. So information about Embassy can be found mainly at its website, on its GitHub website, I should say. There is actually a documentation page associated with all of that, and then there is a presence on the matrix. That link for the matrix can be found under the chat link on that GitHub webpage there, and the community is fabulous. It's very helpful. It's really willing to help you get started with embedded programming in the context of using Embassy. There are plenty of examples in the in the project itself on GitHub, and indeed, I want to say the Embassy is the community is fantastic. So I'm going to jump to a little project here in Visual Studio Code. Now, this is a project that I put together as a result of writing a number of applications for microcontrollers using Embassy. And I hope then that the structure of this will help you get started. I think getting started with embedded is certainly a challenge perhaps. So hopefully this makes life a little bit easier. There is a README associated with this project. It talks roughly about the structure of it, and indeed if we go into the client, there's this client and a server component. So in fact what you can do is you can have two boards and connect their serial ports, their UARTs together, and they will communicate with each other over the RS-232 network. if we go into the client side of things, the client and the server are pretty similar in terms of projects. So we're going to focus just on the client today. It's again got its own README as well. It talks about what you actually need to do to set up the environment. Incidentally, I haven't put up a link on this. I'll put a link up on the notes. But if you search GitHub for embassy-start under our Titan class organization, then you will find it. And so this describes the various components of the app and then how to run it. And so before I get into that, I'll probably just show you the structure over here. So there are two fundamental components or parts to this project. One is what we call app, and the other one is called embedded app. App is Rust standard code. Rust no standard code, meaning that it does not assume an allocator and so forth, but it's very, very useful to put together parts of your firmware, let's say, that in fact are not firmware, that are purely more software. So stuff that is not close to the hardware, but it's not intended to run in a standard environment either. And the advantage of this is that we can actually run this no standard code anywhere. We can run it with our standard projects. We can incorporate tests. We can invoke the debugger on it quite sanely. There are many things that you can do in this environment that you come to expect. And so that documents this. For example, we've used this area to build finite state machines and then are able to sort of test those state machines. We can see here there's an examples folder and a main.rs. And what it actually shows, it uses another project, and it doesn't have to, but it uses another project called Menu, which gives you a command line interface to whatever you want, whatever you build within your app, right? So you can end up in this scenario then when you can test a great deal of your application and develop a great deal of your application away from the firmware itself, okay? Because obviously, that then avoids having to flash the firmware. And in terms of its dependencies, really quite minimal. You'll find yourself using things like Heapless, which is a no standard implementation of VEC and a few other nice things that don't require an allocator. So that's a thing about embedded programming is that we often avoid using allocators, and we end up with highly deterministic code. But it depends on your needs, and you can actually still use allocators if you want. Deformat is another very, very popular one for embedded. We can actually, we can't use it outside of an embedded context, but it does mean that we can annotate some of our structures so that we can use deformat. I just should explain what deformat is. It gives you a logging library for embedded targets and uses under the hood something called RTT, which is a very high performance logging approach to embedded. Okay, so then we look at the embedded app on this side here, and gosh, we see quite a lot of different things going on here. And let's start with the cargo file for a start. So a lot of these dependencies are needed. So Cortex-M is the type of ARM processor that we're targeting. Again, we have deformat in there and how we use it. And then we have dependencies for Embassy itself. Now, Embassy is not yet published to Crates.io. It's still under a lot of development. I would say it's quite stable. I mean, we certainly launched things into production with it, having made lots of contributions, but the way you access it right now is by using Git branch and references with various features enabled. And so this is kind of what you need. And, this is, I guess, the hard part of getting started with Embassy is just understanding, what its dependencies are. But again, feel free to ask on the forum for help in that regard. A few things to point out. Postcard is an excellent serialization library using SERD, the way we can serialize various structures. And then we have this interesting thing is, well, first of all, we're depending on our app as a library, our no standard code that we saw earlier. And we're also depending on a network protocol, and that protocol is what we're going to use between the client and the server itself. And then we enable, we enable various features. This project actually has a number of features because it can run on different targets. So we can run on a 52840 processor, a 52833 from Nordic. We can run on various STM devices and so forth. And then we also have these interesting memory layouts that you have to get used to. You have to understand where in Flash your program lives and where your RAM begins and so forth, right? And these are all different for different sort of processors. Another aspect of Embassy is that it uses nightly. So we pin ourselves to a very specific version of nightly, and that's done because of some of the async future work that's coming. Now I'm running out of time, so I'll show you, in the network protocol here, it's very, very simple. It's, here's a message that we're going to send between the client and the server and so forth, right? So we can define these things as a library and then commonly share that with the server itself. So let's go back to our client and look at what a main RS actually looks like. Some feature enablement, and very similar to what you find with other executors like Tokyo, for example. We declare what is our main task in here, and then we have an example of where we spawn a task, and this one spawns into a task called network peripherals itself, and that one over there is over here. This is the task that it would actually call here, and it's what you would expect from Rust async programming. We use async await, and you can see an await call here, and various things. So another aspect of this is boards as well. We have board support, and the various board support is laid out depending on the target that you have. And for a microbit, then we declare the peripherals that we use. Now this allows us then to write code that is reasonably generic across different targets, across different microcontrollers. Anyway, there's a lot to this, but this project should indeed help you get started. And again, please feel free to ask questions on the Embassy forum, on the Matrix. And because I'm not there tonight, I can't answer your questions directly, but I will answer them on Discord as well. Thanks.